Thank you very much, and you'll have to bear me once more. So again, I'll be basically talking about emergency response itself. And what we saw in emergency response was a VR solution. Now what we are going to see is an augmented reality solution, right? So let me dive in straight away into it. So situational awareness is a critical component to the evacuation process for both first responders and the building occupants, which are the evacuees. So both parties must be aware of the 3D spaces, and when you have a multi-level building, situational awareness becomes even more critical, right? So spatial awareness plays a crucial role in emergencies. It provides insights and it aids in decision-making process. You could look into different evacuation routes. It allows for analyzing historical data as well as topography and critical infrastructure and spaces that could be vulnerable, and define and identify high-risk zones and develop the plans for emergency response accordingly. So one of the ways is to look into using augmented reality. Other things to look into is, of course, visual communication, which provides a quick and intuitive way to understand the information right there on your phone with you. So especially in high stressful situations, even if we know the way, people panic, and because of that, they forget most of the times where they are. And most of the times, even for me personally, when I go to libraries, especially libraries, they are all symmetrical, and when you go into aisle and you come out, you always feel lost, like there are aisles, and where am I right now? So especially with mobile technology and augmented reality being in the forefront, it's a very easy way to find out where you are and where you could go. In order to do that, you need to have a pre-existing knowledge of the space. So you need to build up the 3D model of that building or a 3D space in order to move forward from there, right? So this is kind of looking into visual communication. Visuals such as symbols, icons, maps, and diagrams, they convey crucial details, which becomes important, especially sometimes the use of color, adding different layers on to the information makes a big difference. So I think last year when I came, I presented a paper on mobile augmented reality approach, and that approach we were using Euphoria, and we were using pre-existing maps or pre-existing evacuation floor plans, and then we were adding layers of information on top of it. So this time, this is a different set of mobile application where we have used AR Core instead of Euphoria, and we are moving in real time, and you could actually walk in real time, and the line would actually take you towards where you need to go. So I'll also have a demo for that after the next few slides. So identifying the closest exits and shelter areas becomes important, especially in emergency and places where you have tornadoes. So to overcome this challenge, an AI module was built to help users evacuate the building during emergency. So through the device tracking, the app provides a real-time location update that reflects the user's movement throughout the building. So let me see where my mouse becomes. So out here, this is the model in 3D, which has been modeled. And this is the real space, and the blue line kind of shows where you need to go towards the spot. And you can select the different options from here. So I have to see from there, I guess. So these buttons let you choose which room number you would like to go from. The only key difference over here is that the current location is found through marker detection. So initial location is extracted through image markers. So if anything that is permanent in the building becomes a marker itself that helps in detecting where your location is. We have not been using GPS. We are not using Wi-Fi knowingly because in emergencies, both of them are likely to fail. So, but that also gives you a drawback that in order to have that expandability, it's not that easy to do it for every building. You have to customize it for each and every building. So development and evaluation of this mobile app was there for acquiring spatial awareness, situational awareness, and visual communication. The mobile app shows the 3D model of the building as well as the different room numbers that are there to go to. And then it shows the navigational direction towards the exit. And it provides the current location and the user-specific personalized routes. And the app continuously updates the routes in response to user behavior, reducing the reliance on the stationary and static signage posts that are there. So this is kind of looking into, sometimes it's important that emergency evacuation plans are established and they are communicated to people in real time. So this solution is one way of addressing situational awareness and providing a 3D visualization for a building layout to help people evacuate or navigate the building in real time. So this kind of illustrates the system architecture of the MARA. So the device can either be phone, tablet, or a VR headset. So using the device camera, the user can scan the nearest room marker to establish their initial location. And then the camera continues scanning for room markers until it finds the matching image. So the device contains an accelerometer and a gyroscope that begins tracking the user movement. And then the inertial measurement unit, which records these measurements, are translated into Unity units. So let me see, where am I? So as I said, this used AR Foundation. We used AR Core for Android, AR Kit for iOS. We also integrated the Magic Leap XR plugin and Open XR plugin, and most of the wrapper frameworks. So we have explored it for iOS, for Android, for Quest Pro, and for Magic Leap. So this is kind of showing the navigation panel where you can select the first floor or the second floor, select the wing, then you can select the rooms. The building is kind of huge, so they are like A, B, C, D, K, and F, G wings. So based on those wings, the room numbers will pop up in the select room option, and then you can select those room, and then it will show you exactly how to navigate towards that. We also have something called a mini map, which shows over there on that image, which shows the room numbers and the physical material and the point of interest. So the map depicts a top-down view of the user's location within the context of the surrounding area. The green arrow, which is in the center, indicates the orientation of the user, which way the user is looking. So the implementation was kind of done in 4 phases. The first phase was, of course, looking into modeling the building. So again, it's the same building that we used for the active shooter response project. So the difference being that we had to filter out a lot of things or remove a lot of things because of the weight of the file, and we took it wing by wing instead of that. And then again, so it kind of, we added materials as well as materials by taking pictures in the real world and then including it inside the layout. Next phase was to add building floor plan and location markers, which is over here. And the third one was adding the permanent features of the building, adding markers at local anchors. So when a user points a device at the room marker, their location on the virtual environment updates, and it reflects in the physical position in front of the room. So let me actually see if we can play the demo. But before the demo, I wanted to talk about the last phase, which was adding onto the AI navigation and evacuation. So we added an AI navigation tool to generate the navigational area to match the building layout. So when the user is actually going, let me play this, it might be much more clearer over here. So this is setting up the initial location of where the person is, and then you can select where you would like to go from the drop-down menu. Before that, you have to choose the wing. So the red line is to take towards the exit, and the blue line is basically going from one location to another location, one room to another room, kind of scenario. I guess in the interest of time, I'll move on to the next one. Then you're basically following that line, and it will, the blue one will take you to the room number, and it shows you where that room number is, and the left one was taking you towards the exit. So same one, initially we had created using HoloLens also, but this was something which we created using Euphoria. So this was the floor plans that are there, and then all the floor plans were interactable, so you can touch each and every legend over here, and it will show you where that information is. So it was more interactable that way. And because we had developed it in Unity, we also took it to the tablet and phones. So let me see if I can play some of them. So the previous video was using AR Core. This is using Euphoria, and this is more on marker technology. So this is straight away scanning the permanent signs in the building, which acts as markers, and that projects out your current location and shows you where you are, and then you can select where you would like to go. So as it's constructed in Unity, you could take it to different hardware devices. Let me see how to move forward. I'm stuck. Okay, so talking about the limitations, this app includes approach to modeling and localization. So to create an accurate navigation system, the MARA requires 3D model of the building, which is a labor-intensive process of creating a 3D model by hand. You could actually scan it, but after you scan it, the file becomes too big to be able to use in the first place. Furthermore, it requires users to scan room markers on app for the initialization phase, which might not be practical in high-stake scenarios, so that could be one of the limitations. So this paper kind of presents the mobile augmented reality application for indoor emergency navigation and evacuation, which could be done in real time. So it works with Android devices as well as iOS, and we also tested it in MetaQuest Pro as well as Magic Leap. It features 3D model of the campus building constructed using SketchUp. The building floor plans and models are created, which created a mini-map where key points of interest and exits are marked for potential user destinations. The navigational system deploys the AI navigation tool that allows for dynamic and intelligent route generation. And finally, the device camera, accelerometer, and gyroscope tracks the user's location in real time with the help of AR Foundation. So future work may involve use of the point cloud and photogrammetry using scanner options, which are there in the iOS devices, and to accurately also determine the user's location from the starting point. These are a couple of references and acknowledgement, and thank you very much.